So this is the exam paper 2019, paper 2, question 3, 25 marker, and it's a circle question. We are on part A. It says the point minus 2k is on this circle here. Find two possible values of k where k is an element of z. Now back at junior cert, what we would have had is if a point was on a line, we could sub it into the line and the left hand side equal to the right hand side. It is the exact same here with the circle. There is no need to multiply out those brackets. In fact, I feel it's a waste of time for you to do so. Okay, so don't do that. Let's just sub in the minus 2k, because we know this is the point. Let's just sub this in for x and y. Now where the values of k come from, we'll figure out. There's squares involved, so probably some sort of quadratic. That tends to happen. If I sub in, I have minus 2 squared, plus k, so k goes in for y, minus 3 squared equals to 65. And as you can see here, this actually makes it a hell of a lot easier than multiplying out the brackets to begin with. This is 16. Remember, when you square this out, if you decide to do so now, which I'm actually not going to do for a second, but when you square that out, that's k minus 3 multiplied by k minus 3. If I bring that across, that's k minus 3 squared equals to 49. I'm going to square this using a shortcut, which is the first thing squared plus twice the first by the second, plus the second thing squared equals to 49. So k squared minus 6k minus 40 equals to 0. And this is where my two values of k are going to come from. I would factorise, however, if you have to use the minus b formula, definitely do that. I got k minus 10 and k plus 4. If you put your factors equal to 0, you should get that k equals to 10 and k equals to negative 4. And there are two answers. Fairly straightforward once you knew what was going on with subbing things in. Now again, it's not the only way to do it. It's not the only way to do it, but that's the way I would do it. 10 marks overall. Any relevant substitution got you 4 marks. Grand. If you actually got the centre or radius, like with any circle here, you actually got 4 marks. And your high partial credit came once you got an equation in k squared. So that would have got you 7 marks. But 10 marks overall for getting our two values, plural, for k. We're on part B, and it says the circle S is in the first quadrant. It touches both the x and the y axis. I'd underline that. The line 3x minus 4y plus 6 equals to 0 is a tangent to S as shown. Find the equation of S. So this is a tangent here. 3x minus 4y plus 6 equals to 0. Now, if you think about it here, they've asked me to find the equation of S. Find the equation. So what I personally would do is straight away, because S is the circle here, is I would go to my formula and tables booklet and write this down. This is my go-to formula to find the equation of a circle, because I just need a centre and I just need a radius. Okay, so if I'm not forced to in a GF&C question to use the other one, I would go for this here. Now, we're kind of limited on what we have here. The fact that they told me this is a tangent, I would draw this dotted line in here and make that right angle. That might help us out a little bit, I'm not entirely sure, but if it's a tangent, we always have a radius that's perpendicular to where it touches at the tangent, so that's pretty good. But they did say it touches the x and the y axis. Now what that tells me is something very, very important. If it touches the x axis, the y coordinate of the centre is the radius. So if you have a look at this here, it's touching the x axis here. Okay, so if we have a centre here, that comes from going across, going up, if you think about it here. So if it touches the x-axis, this part here, so if it touches the x-axis, this part here is actually the y value, which is equivalent to the radius. So we know that the centre here is something or, but it actually tells us it touches the y-axis as well. So we actually know that the centre is or, and we also know that the radius is or, which doesn't really do too much for me. But if we go back to this dotted line here, we know that the distance from the centre to this line is equal to the radius, and I know this sounds silly, but the radius is a value of or. So if that's 3, and that's 3. And I can actually find the distance from a point. We do it a lot in the circle, from a point to a line, using something called the perpendicular distance formula. Now, this seems like a bit of a long shot, But if we find the distance from this point to this line, that is equal to the radius, that is equal to r. So that means it's an equation with only one unknown, and that's certainly something I can work with. So what I'm going to do is go to page 19 of my formula and tables booklet, and I'm going to use this perpendicular distance formula. Again, this gives you the distance from any point to any line. It gives you the shortest distance, or as we just said there, the perpendicular distance there. We know that that equals to the radius. When something is a tangent, that equals to a radius. If I was to go ahead and fill these numbers out now, we've got x1, y1 is the coordinate, and we've got A, B, and C in the line. I would always make sure that my numbers are on the same side of the line so I don't mess up any signs here. So I have A, which is 3, times x1, which is r, plus B, which is minus 4, times y1, which is r, plus C, over the square root of 4 squared plus 3 squared, and that definitely equals to r. So now, even though it's a bit messy, I have an equation in r. If I tidy up the top, and then I tidy up the bottom square root, okay, so if you multiply that out and tidy up the r's and add the like terms there, you get minus r plus 6 over 5 equals to r. Doesn't seem that daunting here. If I first of all get rid of the 5, get rid of the fraction, so that equals to 5r. What would I do now? So if I get rid of the fractions there, I've got minus r plus 6 equals to 5r. Now what we can do is we can square both sides, but what I'm going to do is I'm actually just going to make this a little bit simpler. We do not know, do we drop these lines or not? We do not know if we change that minus or change that plus. We have no idea if this is positive or negative here. So what we're going to do is we're going to transfer the ambiguity over to here. So what I mean by that is we have minus r plus 6 is equal to positive 5r, but also minus r plus 6 is equal to negative 5r, If I solve this over here, I get 6 equals to 6r, so 1 equals to r. That seems pretty good to me. But if I actually going to solve this over here, and I bring that r across, we've got 6 equals to, well, that becomes a positive, so we have minus 4r. So we have minus 6 over minus 4 equals to r. So minus 3 over 2 equals to r, but it's a radius, so it can't actually be a negative figure. So that's actually not our answer. Right, now where are we in this scheme of things? We found r. r is 1. But back earlier on in the question, we said that the center was r. So the center is 1, 1. We said the radius was r, so the radius is 1. And back earlier on in the question, we said that all we needed to fill out this formula here is a radius and a center. So now we are actually able to do that. If we do that, if we plug it into this formula here, we've got, we'll put it up here, x minus h, so x minus 1 to be squared, plus y minus 1 to be squared equals to 1 squared, which equals to 1. Now, if you did this using the other equation, you could use your x squareds and your f, g, and c, and you do it that way as well. It wouldn't have brackets, but that's fine. They're still the same value for the same equations. But more importantly, what were the marks like for this? So 15 marks for this question here. If you had something to do with the center where we said or they said minus gg, that gave you 5 marks. Okay, so 5 out of 15. If you substituted into the perpendicular distance formula the way we did here, in some way, that got you 7 marks. If you had the perpendicular distance of the center to the tangent equaling the radius with some substitution, that got you 7 marks. And if you got an equation in G, that's what they did, or as we did it here, that got you 11 marks. So once we got down to this equation here, we got a full 15 marks for finding out what or was, realizing it was the center and the radius, and plugging it back in here. So 15 marks overall for that question, really all centered around you knowing about the idea of it touching the x and y axis.